Okay, it's time for our fourth video for exam 1. Let's see how much we'll get on this one, if we can finish the job or not. If not, we'll have to do another one. Okay, what I meant to do is take something, this is exam 1, review D. And we are working on problem number 14. Problem number 14. Okay, so what it says is solve. It'll use some letter. Well, I'm using W. W squared. They'll use whatever letters they like. They like the letter U also. W squared plus 9W plus 14 equals 0. It's a straight up solving a quadratic equation. You can either use the quadratic formula or you can possibly factor. And we can factor over here. Let me prove that to you. Let's go to our scrap paper. A, we're looking for two numbers. A times B is equal to the last number 14. Right? The same method we've always been using. We've used it so many times. And those same two numbers have to be, when you add them, you get 9. Are there two numbers that can do that? If not, we'd have to use if we can't do this, then we'd have to go to the quadratic formula. But there are two numbers. 7 times 2 is 14. 7 plus 2 is 9. So we've got the two numbers. There they are, W plus 7, and then another W with plus 2 equals 0. Go into the T formation. I loosely call it the T formation. Set up W plus 7 equals 0. And minus 7 on both sides. We can skip a step. We get negative 7 as the answer. That's one answer. One solution to the quadratic equation. W plus 2 equals 0. Minus 2 on both sides. We'll get W is equal to negative 2 as another solution to the quadratic equation. And the problem is done. That's it. Okay, let's go on to problem number 15, which I'd like to put over here. And what does it say? It's asked for the fourth root of, let's use the little U for now, for just as a little off-speed pitch there. Change up. The fourth root of U to the 11. Okay, so now we've talked about this a long time ago. It belonged to the first test as well. We got to break this into two fourth roots, right? Two perfect fourth roots on this side and the leftovers on the other side. So what's the highest number that is divisible by 4 underneath 11? Answer, 8. So put U to the 8 over here. What's the leftover to get back to 11? 8 plus what gets you to 11? U to the 3. 8 plus 3. 8 plus 3. It gets you back to 11. That's the leftover. 8 divided by 4, you just have to divide it. That's all you got to do. And you get U squared, right? 8 divided by 4 is 2. So U squared. Leftover, fourth root. Don't forget that fourth root. Don't forget that fourth root as part of the leftover. U to the 3. And here is the full answer to problem number 15. Let's move up the paper. We can still do more with this paper. Okay, that was problem number 15. How about problem number 16? Problem number 16. What about taking another U again, in parentheses, to the 5th power, to the 2 to the 15th power? So what do we do with the power to a power? Power to a power, you multiply. So let's go to scrap paper. Let's go to scrap paper. How much is 5 over 1 times 2 over 15? Is there any matches between numerators and denominators? Of course there is. 5 goes into 5 once and into 15 3 times. What's left standing after all is said and done? 2/3, that's it. So this becomes U to the 2/3. U to the 2/3, and this problem, it's U to the 2/3 power, and this problem is over. Okay, we've got time on the video, but paper is lacking, so let's go and get ourselves another piece. Here we go. Let's shut this one down. Get ourselves another piece of paper. And let's move on to problem number 17. Problem number 17. Okay, how do you deal with, and we've had this before too, 27 to the 4/3? We said two-step process. Step 1, concentrate on the denominator, and that is going to be the root. We're looking for the cube root of 27, the base. The cube root of 27 is 3. That's an interim result. That's not the answer. Step 2, we kept talking about this as a two-step process. Take that 3, the interim result, and go now concentrate on the numerator, raise it to the 4th power. 3 to the 4th power is 3 times 3 times 3 times 3, 4 copies, is equal to 81. This is the final answer for problem number 17. Okay, problem number 18 might take a little bit of paper going down vertically, so I want to start use of the vertical rest of the paper that I have here. I've got an R there, followed by a 27, then a W, then an R to the 4. Over here, that's on one side. On the other side, minus 7W, square root. They're both square roots. Minus 7W. Then I've got 48, followed by W to the 5th power. Okay, we've got to break this down. We've got to break this down into perfect square roots and leftovers. That R, don't forget that R, we'll take care of it later. Okay, 27. What is we can break it down into two numbers that multiply back to each other, back to get to 27. They multiply each other back to 27, and one of them is a perfect square. And those two numbers is 9. There's our perfect square, and the leftover is 3. How about the W? Is that a perfect square? No way, it's just a born leftover. And then R to the 4 is itself a perfect square. No leftovers, it's a perfect square, so it belongs on that side. What does this become when we let me bring down the R now. I could bring it down here, keep doing it, but this is going to be multiplying. This is trying to multiply whatever's next door to it, so it's going to be multiplying this. What's the square root of 9? 3. What's the square root of R4? R2. Okay, and then the leftover is going to be 3W. That's not changing. All right, bear with me for a second. Well, we got one more thing to do. The R times the R squared, so I have 3R cubed, square root 3W. Okay, now let's do this side. Break it down into two pieces, right? The negative 7W is going to have to multiply them, but let me get the two pieces here. The perfect square is on the left, and the leftovers on the right. 48, is that a perfect square? No, but we can break it down into a perfect square and a leftover. 16 times 3 is 48, and 16 is a perfect square. How about W5? Is that a perfect square? No. Take the number that's divisible by 2, the greatest number that's divisible by 2 underneath 5. That is W4. W4. What's the leftover? W. 4 plus 1, back to 5. Okay, here's the perfect squares, and here's the leftover. Well, minus 7W is coming down with us, right? It's trying to multiply whatever's here. Hold on. What's this? This will turn into 4. All right, square root of 16 is 4. Square root of W4 is going to be W2. Always just divide it in half. The leftover is a leftover. And minus 7W is still hanging around trying to multiply. What do I get over here? Minus 7 times 4 is negative 28. W3, square root of 3Ws. Okay, are these two now, we're looking at that now. Do we have the like terms now? Square root of 3W, square root of 3W? Yes, we do. So I ran out of room, but I no use going to another piece of paper. The final answer is 3R cubed minus 28W3, just read it right off the bottom line there, all of that, square root of 3W. Problem over. This has got a roof over it, and this you just write just exactly like that, no roof over that. And that is the answer to problem 18. Okay, whatever time we have left, let's go to the to another piece of paper. Okay. Another piece of paper. Here we go, and we might be able to do problem 19. Problem 19 has an asterisk because we haven't learned it yet as of me doing this video. By the time at one point, we'll have done it. But as of September 30th, we didn't do this yet. But I'm putting it on this video for the future, and maybe you can take care of it yourself. You might figure this out yourself. But I'm going to show you how to do it. But we didn't cover it yet. We didn't cover it yet. There's going to be 2 problems like that. Only 2 problems, 19 and 20. I saved them for last. Okay, here comes problem number 19. It looks like this. 1/9 W minus 2 less than or equal to 5W minus 8/3. Minus 8/3. Okay, so this is what you haven't seen before, less than or equal. At some point when you look at this review, you will have seen it, but not as of 9/30, September 30th, right? September 30th. Okay, so we need to use common denominator. Some of this we've done before. We need an LCD, and it is easy. 9. 3 goes into 9, and 9 goes into 9. That means multiply every piece of this times 9. Multiply the 1/9 W times 9. Multiply the 2 times 9. You could put the minus in front or in back. Less than or equal, which is the new thing, but multiply this times 9. And multiply this times 9. Every single piece by 9. Okay, what does this do? 9 and 9 cancel each other out. What do we have? We have a W. This becomes minus 18. This becomes less than or equal. This is going to be 9 times 5W is 45W. And this 3 goes into 3 once, into this 3 times. Minus 3 times 8 is minus 24. Okay, let's get the W's on the same side. I don't want this W. So I'm going to do minus W on this side and minus, I can't have W's on both sides. Just like a regular equation. Minus W on both sides because I gotta get rid of one of them. I'm getting rid of this. What do I got? What do I have? Negative 18. Keep the sign as it was, less than or equal. We don't flip it. Sometimes we do flip it, but we're not flipping it here. This is 44W minus 24. Let me move this up. I might as well try to get some more space here. Right? Okay. Now, I got numbers on both sides. I'm going to get rid of this. Plus 24 and plus 24. What is this? 24 negative 18 is 6. Less than or equal. No flipping the sign at this point. And this is 40. This is gone. This is 44W. Divide by 44 and divide by 44. What do you get? 44 divided by 44 is going to be plain W. Then there's the less than or equal sign. And 6 over 44, 2 goes into 6, and 2 goes into 44. 2 goes into 6 3 times. 2 goes into 44 22 times. And here is the final answer. What will it look like on an answer sheet? How will Alex want you to write it? Will want you to write it W first. Then this is less than or equal, but this, reading it the other way, it's greater or equal to 3 over 22. Okay, there's one more to do on one more video. And we have to end this video though.